All right, let's talk about a fascinating little piece of automation that is quietly working all around you, probably every single day. We're talking about the controlled delay, the secret reason why some things just don't shut down the instant you hit the off switch.
I mean, you've definitely noticed this, right? You flip the switch, you walk out of the bathroom, and you can still hear that fan whirring away for a little while. It might seem a bit odd, but trust me, there's a very specific and actually pretty clever reason for it.
And here it is. The answer is the timer off delay, or TOF for short. It's a really simple but powerful command that basically tells a device, hey, when you get the signal to stop, I want you to just hang on for a second before you actually do. It's a delay, but it's for turning off, not for turning on. So let's really get to know this timer. Its entire mission in life is to manage that transition from on to off. It makes sure that a process doesn't just stop cold, but instead shuts down in a controlled, predictable, and often much safer way. It's all about preventing damage or just weird results. Now, it is so important not to get this confused with its more famous cousin, the timer on delay, or TON. You know, a TON timer makes you wait before something turns on. But our hero today, the TOF, is all about that graceful exit. The absolute key difference is when the clock starts ticking. For a TOF, the countdown begins the moment that input signal stops. So, how does it actually pull this off? Let's take a little journey through the timer's logic. You'll see it's a super straightforward process once you see it laid out. Okay, so here's the play-by-play. Step 1, you flip the switch on. The fan, or whatever it is, turns on instantly. No delay. The timer is just sitting there, its clock is at 0. Now, step 2, you flip the switch off. And this is the magic moment. The fan, it stays on. And the timer's internal countdown finally begins. During step 3, that internal clock is just ticking away, accumulating time. And finally, step 4. The clock hits its target, time's up, and only then does the fan actually turn off. See? Simple? But what if you change your mind? Let's say you flip the switch off, the countdown starts, but then you flip it right back on again. Well, the TOF timer instantly slams its clock back to 0. It stops counting and just waits for the next time you turn the input off. This is what we call non-retentive. It doesn't hold a grudge, it doesn't remember the last countdown, and it doesn't need a separate reset command. It just resets itself. So, to really understand what the timer is doing from one moment to the next, we can look at its internal status bits. Honestly, the best way to think about it is like a little dashboard that tells us exactly what's going on under the hood. This dashboard has a few key indicators. The enable bit is easy. It's lit up when the input is on. The done bit is the one that's actually keeping the fan running. It's true when the input is on and during the countdown. The timer timing bit, well, that's only true during that specific countdown period. And all the while, the timer is comparing the accumulated time, how long it's been counting, to the preset time you programmed. The second they match, the done bit turns off, and so does your fan. Okay, so we get how it works, but where does it actually matter? Let's look at some real-world applications, because you'll find these things everywhere, especially in some really critical industrial settings.
Oh, the versatility is just incredible. In factories, you'll see it running a cooling fan on a huge motor after it's shut down, to prevent overheating and make the machine last longer. For safety, it might keep a warning horn blaring for a few extra seconds after a machine stops, just to make sure everyone is clear. On a conveyor belt, it makes sure that very last package gets to the end before everything stops. And yep, it's the exact same tech that keeps the stairwell lights on long enough for you to get down safely. It's all about providing that crucial extra little bit of time. So the big takeaway here is this. The timer off delay is your go-to tool anytime an abrupt, instant shutdown is just a bad idea. Whether it's for cooling, for safety, or just to finish a process, it gives you that graceful, controlled delay that makes so many automated systems work better and last a whole lot longer.
So, the next time you see a fan that stays on a little too long, or a light that lingers after you leave, you'll know the secret. It's the timer off delay doing its job. And that kind of leaves me with a final question for you. Now that you're in on the secret, where else do you think a perfectly timed lingering on could make things just a little bit better?